Hello and welcome back. This is part 2 of the inbuilt Python functions. So in the previous part we covered input, enumerate and map functions, and now we're going to cover 3 more important functions. We will begin with the Python sorted function. So when you have a list of elements, you want to sort it out. This is the function Python sorted that you're going to use, and we'll jump straight to the code and see how it works. So say we've got a list of vowels. I'm going to call it PyList, and these are my vowels E, A, U, O and I. Now obviously these are not in sequence, they are out of order. So if I want to print them out in sequence, I'm going to use the sorted function. So I'll say print sorted, and then I'm going to give it the list that I want printed. So it's going to print out the vowels sorted out like this, A, E, I, O, U. So as you can imagine, this is very helpful if you are trying to have a large list where there's a lot of elements and you want to sort them out. Impossible to do by hand, but Python makes it work really fast for you. Let's take another example. We got PyString is equal to Python. Now strings are ordered objects in Python, and they are just like a list. Each individual one is not only a separate item within that thing, it's also indexed. So P would be occupying index position 0, Y would be occupying index position 1 and so on. So it is possible to treat Python as an iterable, and then we want to sort it out like any other iterable. We can do that. So if we say sorted PyString, it's going to sort out these letters and it's going to give us P, H, N, O, T and Y. So this is how Python is sorted out. Now you will notice that the P has appeared first, and then we have H, N, O, T and Y. So this is because of the uppercase and lowercase difference. Uppercase letters come at a priority, lowercase letters are then placed after that in the sorting order. Now let's see a tuple. Again, the same tuple as the list that we had here. The contents are the same, only this is a tuple. Now you might think that tuples are immutable, so they might not be, they cannot be changed, but we can still sort them. And you know, when the printed sorted order comes, it comes out in the form of a list. The reason is that the sorted function outputs a list back to you, irrespective of what it's got. So whether you give it a list or a string or a tuple, it will give you back a list. And the reason for that is it's not changing the originals. So here our tuple is not being changed at all. It's only printing it out in a sorted manner. But if you were to print out my tuple again, it will give you the same tuple in the same sequence. So sorting doesn't change anything in the original data that you have. It just gives you the values in a sorted list form. So that's it. Now we can sort in a ascending order by default, which is this segment of code. But we can also ask Python to sort in descending order, and for that we have to pass an argument saying reverse is true. So by default this is false, but if we say reverse is true, then Python knows that I have to reverse the order of my sorting, and so in this case the order becomes the other way around. So instead of starting with A, we are now ending with A. A dictionary can also be sorted, but Python will return to you the sorted keys of a dictionary if you don't specify anything else. And a frozen set, like a tuple, a frozen set is also immutable, but it can be sorted. Now in a set, obviously the order doesn't make any difference. So even if it is immutable, you might want to sort it in place, but because there are no index positions, so you can't do it within the set, it will still return a list to you. So every time you use the sorted function, you're going to get back a list of the elements which are then in sorted position. Whether in ascending or descending order is decided by this little bit, reverse is true or false. If it is true, then the descending order is used. Now let's see how we can specify a key parameter in the sorted function. So the overall syntax would be, I want to pass sorted, I give it an iterable, and then I specify a key by which I want to sort it. So I can say, for example, I want to sort by the length of these numbers, these strings that I have given you. In that case, in ascending order, Python will put the smallest string in the beginning and the largest string at the end. But len is just one function, and you can also give it any other function. So you could even define your own function and pass it on. So let's take an example of doing exactly that. Here we are defining a function and we are calling it take second. We're going to pass it something, and it's going to return to us the second element from whatever it is that we have passed it. So this is the import of the function. What the function is doing is it's giving you back the second element. Now let's have a random list here. So we have defined a variable. a list comprised of 4 tuples. Each tuple is a 2 element tuple. So we've got 2 2, we've got 3 4, 4 1 and 1 3. Now when we try to sort it with this line, sorted list is equal to sorted random key is equal to take second. So let us take a moment and see what this line is doing. It's going to evaluate this expression on the right hand side, and whatever comes from this expression is going to get stored in the sorted list variable. So this is just our container to print later. What is actually happening is all happening on this side. So we are using sorted. We understand how sorted works. The iterable we are passing to sorted is our random, which is this list right here. So we have told Python, look, I want to sort this list. But we have also told it that you have to take this function in order to get the values that you're going to sort. So when random throws up 2 2, the first tuple, Python has to be able to tell which one of these is to be used. So it says, okay, let me use the function key second, take second. So Python is going to pass this whole tuple to this function as an element, and this function is then going to return the second element. So it's going to return 2. So in this situation the key is 2. Here the key becomes 4, then it becomes 1, and finally it becomes 3. So these are the values, the second values 2, 4, 1 and 3 that are being generated by this function. And Python is going to sort based on this key. So when we actually run this whole code, we get this output. So we get a list. We know we're going to get a list from the sorted function, but look at the first function, value returned. So that is 4 1, because the 1 is the element that is being used for sorting. So we get 1 in this position, then we get 2, then we get 3, and then we get 4. So this is how we can sort a list using the sorted function with a key function given as an argument. So this covers the sorted function. Now let's go to the iter function. Iter and next go together. We'll talk about both of them. So what does the iter function do? The iter function will take an object, an iterable object, and return to you an iterator. An iterator is something which can give you an iterator is something which can return the iterated elements one at a time. So it will become more clear when we look at the actual code. So here we've got a list of vowels, and this list is A, E, I, O and U. So there are 5 elements in my list. I pass the whole list to the iter function, and I got a vowel iter variable which is an object of iter, which is returned from the iter function. Now the iter function that has been invoked here, what exactly is contained in this variable? What have I gotten myself into? What is this thing, vowels.iter, vowels_iter? So this is going to contain all of these elements, but they are ready to be sort of popped off a stack, as if to say. So if you are familiar with computer science and stack variables, this is what's happening here. When we say print next vowels iter, it gives me A, because A is the first thing top of my stack here. Then it says the same line again. So the code lines are exactly the same. 5 times you have used the same line. It says next vowels iter. Now A has already been issued, so internally Python knows that it's already given me A. So the next time I run the command using next, it's not going to give me A, it's going to give me E. So this is how it goes through the whole sequence one by one. And when it ends, if I try to use the next function again, well, let's see what happens. Let's come to a little bit more detail about the next function. So we're using the next with our iterator object. If we do not give it a default value, and if we run out of objects to iterate, then it's going to throw an error. But if we give it a default value, then if it finds nothing to give me from that stack, it's going to instead return the default value. So that is a way to prevent an error. So let's take another example here. We got this list random, which has got 5, 9 and cat inside it. We create an iter object out of it. We say random iterator is going to be whatever you return from iter when I passed random to it. So this whole thing goes into the stack within the random iterator. Then I try and print random iterator. Let's run this, where it tells me that I got a list iterator object. So this is what has been returned from this So this object is there for me. Printing this object doesn't give me any of the values, it just gives me the address of that object in memory. If I want values, I need to use the next operator, next method. So I say print next and I give it my random iterator. So when I do this, obviously it's going to give me the very first element. When I do it again, it's going to give me the second element, which is 9. When I do it for the third time, the cat is let out of the bag. And when I do it for the fourth time, now Python doesn't have anything left for me, so it's given me an error that sorry, we are all out of objects in your iterator. So here this is the line, the last one, which has caused the error. How can we correct it? So just like we discussed, we use a default option. So here's the same situation again, but now we've got only two elements, 5 and 9. We are iterating over these elements by using next, but this time we are also giving it a default value of -1. So every time we run this line, we are telling Python, I want whatever it is you have on the stack after whatever has already been given to me. So give me 5, then it will give me 9. But if you don't have something on the stack, then I want you to return -1. And this -1 will be your way of telling me that you are out of the stack instead of raising an error. So let's run this. So we get 5 for this, we get 9 for this, and for these 3 lines, there's nothing left on the stack, there's nothing left from this list to return, so it's just going to give me -1 every time. It doesn't matter how many times I run this, I will not get an error because I have defined the default here. So you can imagine that instead of typing this line 3 times or 5 times, I can well run it within a loop and get those things one by one till I come to an end, and a nice conditional can be put in that will stop the loop when I hit -1. So this is the way the iter and the next functions in Python work. Now let's come to an interesting function called zip. Now what zip does is, it takes 2 iterables, it could be anything, and then it puts them together in a tuple. So it sort of zips them. Now it could take more than 2 also, but we'll start off with 2. So as you are aware of the function of a zipper, it's going to take one element from each of the iterables we give it, and those 2 elements, one from each, are going to be bound together. It will keep on doing this till it runs out of elements in one of the iterables. So the first time it comes across an iterable element which cannot be paired, then at that point of time the zip function stops. So the syntax of the zip function is very straightforward. You say zip, and within the parenthesis you give it any number of iterables. Let's take a look at how the function actually works using code. So we gave it a number list which has got 1, 2 and 3. We have a string list which has got 1, 2 and 3 in the form of strings, and we are going to use result to store whatever comes out of this zip. So in the zip function we are passing it both of these 2 structures that we have created. We are giving it number list as well as string list. What happens when we print this? So we are going to convert it to list because this is not going to be printable except as an object. So we want to see the actual results, therefore we convert it to list, and once we run it, we get, you can see tuples. This is the first, second and third tuples. We got 3 tuples because there are 3 elements in each, and each of the 3 could be paired. So 1 could be paired with 1, 2 could be paired with 2, 3 could be paired with 3. So these are obviously going to be in sequence, and we get this outcome here. So effectively Python has zipped together 2 iterables for us. Now what happens when there are a different number of iterable elements? So like we discussed, the moment Python runs out of elements to pair, then it stops at that point of time. So here we have 2 structures, numbers list which is 1, 2 and 3, and a numbers tuple which is a tuple containing these 4 strings. So here we've got 3 elements and here we've got 4 elements. So let's combine them using the zip function. We pass both the variables, convert it to list, and then we print it. So the outcome is 1 got paired with 1 here, 2 got paired with 2, 3 got paired with 3. When it came to 4, there was nothing to pair it with. So our output of that zip is not going to contain 4. It's just going to simply drop this from the zipped outcome. So zipping only happens to the level that we can pair them together. If there are 3 values, then all 3 have to exist. If of the 3 even 1 is missing, then that, and therefore thereafter we are going to just dump all the remaining variables. Now once you have zipped something, you would obviously want to unzip it at some point of time. So unzipping is also quite straightforward. Let's see how it works. We've got letters here which are X, Y and Z. We've got value which is 3, 4 and 5. So these are the two iterables we're going to zip together. Our result is zip of letter and value, and then we print this result. Let me just print it out like this. And you can see here the result printed is X3, Y4 and Z5. So one to one Python has zipped them together. Now to unzip it, we pass the zip asterisk and the result list. So this is our zipped object, result list. It contains the list form of the result which we got here. So these are pairwise tuples. Now we pass the thing with the asterisk in front of it, which is what is telling Python that we want to unzip it now. And when we unzip it, we're going to get two values out of it. So we pass them to L and V. So L and V will store one from each. And then we can print them out individually. So we can say letter is equal to L and value is equal to V. So we see here now that we got a tuple containing X, Y and Z. So from X from here, Y from here and Z from here, and a value containing 3, 4 and 5. So this is how it works. Unzipping returns you two tuples or more if you've got more zipped elements in there, but two in this case. And of course tuples can be converted to lists if you so require. And so with that we come to an end of our brief session on inbuilt Python functions. I hope you enjoyed it. Thank you for watching and see you in the next one.